This video is on operations with complex numbers. All real numbers are part of a larger set of numbers called complex numbers. So all complex numbers are either real or imaginary. Imaginary numbers use the imaginary unit I, written as a lowercase I. It is the number whose square is -1. That is, I squared is equal to -1. So if you were to take the square root of both sides, I is equal to the square root of -1. This is how we can deal with the square root of negative numbers in math. Let's take a look at an example here. So we need to simplify the expression square root of -24 using the imaginary unit I. So the square root of -24 is equal to the square root of -1 times the square root of 24. So the square root of -1 is the imaginary unit I, and the square root of 24, since that's 4 times 6 and the square root of 4 is 2 square root of 6. And then the way we usually write this is we usually put, if there's any number in front of the square root, we put that first, and then we put the I, and then the square root. So the square root of -24 is equal to 2I square root of 6. A complex number has the form a plus bi, where a and b are real numbers. So for example, 3 plus 4i is a complex number. The real part of the number is a, that is in this case 3, and the imaginary part of the number is bi, or in this case 4i. If b is equal to 0, then the number a plus bi is a real number. So for example, so if b, instead of this being 4, if that were a 0, we'd have 3 plus 0 times I. 0 times I is 0, so it would just be 3. So when b is equal to 0, a plus bi is a real number. If a is equal to 0 and b is not equal to 0, then the number a plus bi is what we call a pure imaginary number. So for example, if a is 0 but b is not, then we have 0 plus 4i, or just 4i, which is a pure imaginary number. Here's a little diagram to kind of explain what's going on here. So all numbers are complex numbers, a plus bi. If b is equal to 0, then that's called a real number. If b is not equal to 0, then they're imaginary numbers. And pure imaginary numbers are those in which a is equal to 0. To add or subtract complex numbers, we want to combine the real parts and the imaginary parts separately. To multiply two complex numbers, we're going to use the distributive property. So let's take a look at several examples here. We need to simplify each expression. Here we have the complex number 2 plus I being added to the complex number -3 plus 3i. So we're going to take the real parts and combine those. So 2 minus 3 is -1. And then we'll combine the imaginary parts. I plus 3i is 4i. I know you might want to think of I being like a variable. It kind of acts like a variable sometimes, but really it's a number. It's the square root of -1. Subtracting, so I'm actually going to rewrite this one. So -6 minus 2i, and I can think of this as a -1 that I distribute, as though I were subtracting polynomials. Minus 4 minus 2i, and then combining the real parts, I get -10. Combining the imaginary parts, I get -4i. So -10 minus 4i. Here we have -I times the quantity 4 minus 8i. And so I'm just going to use the distributive property. So -I times 4 is -4i. -I times -8i is a positive 8i squared, because I times I is I squared, but recall that I squared is -1. So this is the same as -4i plus 8 times -1, or -4i minus 8, but let's write that in a plus bi form, -8 minus 4i. Whoops. And our last example is multiplying two complex numbers. 5 minus 7i times the quantity negative 4 minus 3i. And so this is going to be very similar to multiplying two binomials. So I will distribute the 5 to the negative 4. That gives me negative 20. And then 5 times negative 3i is negative 15i. Negative 7i times negative 4 is a positive 28i. And negative 7i times negative 3i is a positive 21i squared. So that's going to give me negative 20, and I can combine these, plus 13i, and then remember that I squared is negative 1, so negative 1 times 21 gives me a negative 21. So this is going to equal negative 41 plus 13i. So in this video, we took a look at operations with complex numbers, what a complex number is, and how to add, subtract, and multiply those values.